In this module, we shall discuss some more results on direct products. In the event that the operation of each GI is commutative, we sometimes use additive notation in direct product I equal to 1 to n GI and refer to the product I equal to 1 to n GI as the direct sum of the groups GI. The notation direct sum I equal to 1 to n GI is sometimes used in this case in place of direct product I equal to 1 to n GI, especially with abelian groups with operation addition. The direct sum of abelian groups G1 up to so on Gn may be written as G1 direct sum up to so on direct sum Gn. Now we state the proposition: a direct product of abelian groups is abelian. And to prove this, as you know that we need to prove the commutative property. Let G1, G2 up to so on Gn be abelian groups, and we are choosing two arbitrary elements in the direct product of GIs. That is A1 up to so on An and B1 up to so on Bn belonging to the set direct product I equal to 1 to n GI. And in the previous theorem, we have proved that this direct product is group. And only thing is remaining to prove that we need to establish that the commutative properties holds in this set. Now we are multiplying A1 up to so on An with B1 up to so on Bn, and we are using the definition of multiplication in this set A1 B1 up to so on An Bn. And as you know that each GI is a group, therefore each GI is an abelian group, therefore AI BI equal to BI into AI for every I equal to 1 to n. So we are going to use this property at the level of each component, and we shall obtain B1 A1 up to so on Bn An. Now we are using the definition in reverse order, definition of multiplication, and we shall obtain B1 up to so on Bn into A1 up to so on An. In this manner, we have established that commutative property holds in direct product I equal to 1 to n GI. And therefore the direct product of abelian group is abelian.